Today, we're talking about something that I think is honestly underrated in the whole AI app conversation right now. Everyone is obsessed with RAG, Retrieval Augmented Generation, vector databases, embeddings, the whole stack. And RAG is fine, it works. But there's a different shape of data that your brain actually uses that handles a whole class of questions that RAG cannot touch. And it's way cheaper to build than people think. That's the knowledge graph. So here's the plan. First, a quick refresher on RAG and where it falls down. Then, what a knowledge graph actually is. Then, the trick is how to build one literally with a JSON file and 3 C# classes. And we'll do a deep dive on 2 real open source applications that do exactly that. Real quick on how RAG works, because we need this as a baseline. You take your documents, your PDFs, your wiki, your support articles, and you chop them up into little chunks, maybe a few hundred characters each. Then, every chunk gets sent through an embedding model that turns it into a vector, basically a long series of numbers. Then, at query time, you embed the user's question the same way. You do a cosine similarity search against every chunk, and you grab the top few matches. You shove those into the prompt as context. The LLM answers, and like I said, that works. It really works well for one specific type of question, which is, find me a passage that talks about X. It's basically a very fancy fuzzy search. But that's where it falls apart. Try asking these questions. What tickets did the user comment on, but never got assigned? What characters appear in chapter 4, but never speak in chapter 5? What's the average number of categories on an open ticket? None of those answers live inside a single passage of text. They live in the relationships between things. And cosine similarity has absolutely nothing useful to say about relationships. So what is a knowledge graph? Honestly, it's exactly what it sounds like. Instead of storing data in tables that you have to join together, you store it as a network. You have nodes. Those are your entities, things like a customer or an order. And you have edges. Those are the relationships between them. Customer node connected by a placed edge to an order node. The structure of the data is the meaning of the data. And that turns out to be a huge unlock, because when AI asks, show me everyone who touched ticket number 42, a graph can answer that in literally one hop. No joins, no similarity search, no vibes-based ranking. The technical term is a directed label property graph. Sounds fancy. It really isn't. Directed. The arrows have a direction. Labeled. Every node and edge has a type, like customer or purchased. Property. Nodes and edges can carry key value data, so the purchase edge itself can hold a date and a price. So no extra join table is needed. So the obvious question is, if graphs are so great, why isn't every app using one? Well, the marketing for graph databases has convinced everyone that you need expensive products such as Neo4j or Amazon Neptune or Cosmos DB. Big enterprise tools that are expensive, operationally heavy. They bring a whole new query language with them, like Cypher, Gremlin, SparkQL. Pick your poison. You're now patching another server, paying another cloud line item, another backup job, another monitoring dashboard. Another thing your team has to learn. For most business apps, that's an absolute overkill. And here's the dirty secret no GraphDB sales page is going to tell you. Most apps don't actually want a wide open, anything can link to anything graph. You want the opposite. You want strict rules, bounded entities, predictable application logic. An enterprise graph database is a wrong tool for that. So here's the move. Once you see it, you can't unsee it. You build the knowledge graph as a plain text file, JSON, Markdown, YAML, whatever. You load it at startup into a handful of C# objects, basically a node class, an edge class, and a dictionary. That's it. You get all the relational power. You get graph traversal speed because it's all in memory. You get the structure that an LLM can reason about, and you spin it up, zero new infrastructure. No new server, no new licenses, nothing new to monitor. The big takeaway, and this is the part I actually want to internalize. When your domain is small and bounded, a JSON file is more than enough to power a real intelligent graph-backed AI. You do not need more. So how do you find a knowledge graph in something you already have? Easiest hack in the world. Open your database. Look at any details table that's related to another table. Orders table with order items, graph. Task table with task details, graph. Stories with chapters, chapters with paragraphs, graph, graph, graph. Anywhere where you've got a parent-child or many-to-many relationship that the AI is being asked to reason about, that is a knowledge graph in your schema. Now let me show you two real apps that do exactly that. One is read-only, and one is read and write. The first app, ADefHelpDesk. It's an open source help desk system that I designed many years ago, still available. It's a totally normal Blazor app. Its database is dominated by four concepts: task, the task ticket itself, task details, the rolling comment log on each ticket, categories, the bucket each ticket sits under, and users, the people requesting, assigned to, and commenting on the tickets. This is a textbook details table inside details table pattern, multiplied by 3. It's also exactly the data shape you need to answer questions like, how many tickets has Bob commented on last month? Or, which open tickets in the network have no assignee? So, there's a companion project, ADefHelpDesk Graph Explorer, that points to the ADefHelpDesk database. It builds a lightweight knowledge graph. It visualizes the graph in the browser and lets the LLM chat with it. Let me walk you through how it's built. Step 1. Before any code, the author, myself, sat down and mapped the schema to a directed labeled property graph. Nodes first: task, task detail, user, category, and a synthesized requester node for tickets where the requester is just a free-form text name. Then the edges: requested by, from task to user, or requester assigned to, from task to user, in category, from task to category, child of, between categories for the hierarchy, has detail, from task to its comments, and authored, from user to task detail. That's it. 6 edge types, 5 node types, and the entire domain. Step 2, the C# model. 6 edge types, 5 node types, the entire domain. Step 2, the C# model in 3 classes. That's the whole format. There's a graph document with a version, a generated UTC timestamp, and 2 lists, node and edges. A graph node has an ID like task42, a type like task, a label, and a dictionary of properties. A graph edge has from, to, a type like requested by, and its own property dictionary. That's the entire graph schema. 3 classes, 1 JSON file, 0 new infrastructure. Step 3, build it on demand. There's a class called HelpDesk Graph Builder with a build async method. It walks the ADefHelpDesk tables exactly once. Task details, users, categories, produces a graph document that gets serialized straight to app data, and basically goes to a file called graph.json. The build is triggered either by navigating to the graph page or by clicking the rebuild button. From that moment on, every query is an in-memory dictionary lookup. No SQL, no round trips. Step 4. For the visualization, the app uses VizNetwork, a small JavaScript graph rendering library loaded from a CDN. The Blazor page exposes an API graph.json endpoint and renders an interactive force-directed graph with click-to-inspect and faceted filtering. Roughly 50 lines of JavaScript for the whole visualizer. VizNetwork was the right pick over heavier options like Cytoscape, Sigma, or D3 Force because it just ships everything we need. Step 5, the part that gets really exciting. Let the AI chat with the graph. The chat page is built on the same iChat client abstraction from the Microsoft extension AI. Multi-provider, OpenAI, Azure OpenAI, Anthropic, Google Gemini, all behind one interface. But here's the twist. Every chat turn ships a list of tools, functions that the AI is allowed to call that read the knowledge graph. The contract lives in an interface called iGraphChatTools, and it's basically a menu of graph traversals, things like search nodes, get node, get neighbors, list tasks for user, count tasks for user, get user activity, list comments for task, list task in category, get task participants, get category rollup, find users by name, and a stats method. Each one is a thin deterministic query against the in-memory graph. The way the tools get registered is really clean. Microsoft Extensions AI has a class called AI Function Factory that produces the JSON schema for each tool automatically from the C# parameter signatures and description attributes. You write a normal C# method, decorate it, and the framework generates the tool definitions that the LLM sees. You never handwrite the JSON schema. So when the user asks, how many tickets did Bob work on? The model calls find user by name Bob, gets back a user ID, then calls count tasks for user with that ID, and reports the exact number. No embeddings, no similarity threshold, no I think it was about. The answer is correct, and every tool call is visible in the chat panel, so it's fully auditable. The model never sees raw rows, only sees graph traversals. That is the whole ADefHelpDesk Graph Explorer architecture, and honestly, the code surface is small enough that you could read it in one afternoon. Let's look at the second example, and this one is a whole new dimension because the AI can now write to the graph. AIStoryBuilders is a .NET MAUI desktop application for novelists. It helps you plan, write, and continuity check fiction. And the novel turns out to be a canonical details table inside a details table inside a details table. Watch this domain breakdown. A story is the top level work. Title, style, synopsis. Inside that, you have timelines, named time slices, each with a start and end date, like Act 1 or the flashback sequence. You then have characters. Every character has a time scope, descriptions, appearance, goals, history, aliases, facts. So Alice in Act 1 might be a teenager with brown hair, but in Act 2, she's an adult with gray hair. And the graph knows both. Same with locations. Then you have chapters, and chapters contain paragraphs, and every paragraph is tagged with a timeline, a location it's set in, and the characters who appear in it. Stored as a graph, it's quite beautiful. A paragraph node has in timeline, at location, and feature character edges. A character node has attribute edges, 2 per timeline attribute nodes, and those attributes themselves carry an in timeline edge. So a question like, what does Alice look like in Act 2 becomes a simple 2-hop traversal. Alice has attribute appearance with timeline ID Act 2, and instead of some gnarly SQL filter, the user just asks the AI things like, critique chapter 1 in plain English, and the AI walks the graph to answer. Where the graph lives on a disk, this is one of my favorite parts. The story is just a folder. Open it in Explorer and look under My Documents AIStoryBuilders, your story title. You'll see folders for characters, locations, chapters, timelines. You'll see a CSV file and a graph subfolder with 3 files, a manifest.json, which has counts, versions, infos, graph.json, the actual code, and the edge data. Metadata.json has genre, theme, synopsis tables. That's it. The whole knowledge graph is in files in the folder. No server, no daemon, no migration scripts. You can zip it up and email it. Read tools and write tools. The Maui app has a class called Story Chat Service that exposes 2 flavors of a tool to the LLM. On the read side, you've got get characters, get locations, get timelines, get chapters, get paragraphs, get character relationships, and a bunch more. All those run against the graph query service and never modify the state. They're safe to call freely. Note, for this next section, I'll also mention embeddings, but those embeddings are already part of AIStoryBuilders. They're not actually part of the graph. On the mutation side, we've got add character, update character, rename character, delete character, add location, add timeline, add chapter, add paragraph, update paragraph, and even re-embed the entire story that rebuilds the embeddings. All of those go through a separate graph mutation service, which literally is the only component that is allowed to write to the disk. That separation is on purpose. The read path and the write path cannot accidentally bleed into each other. The 2-phase commit pattern, that is the safety net. Letting the AI change someone's novel is terrifying, so the system prompt enforces a rule. Every mutation tool gets called twice. The first call is a confirm equals false. That runs just a preview. It tells the user, here's a diff, here's what files will change, and here's whether embeddings need to regenerate. It doesn't write anything to the disk. Then the user looks at the preview and then clicks approve. Only then does the model call the same tool again. This time, the confirmation equals true, and that's when the actual change actually lands. So, in practice, the AI produces a diff, the user accepts, the disk is updated, the graph rebuilds, embeddings refresh where needed, and the chat continues. The user is in the loop for every single write. You can audit every tool call in the chat panel. The GitHub repo has a whole knowledge graph integration plan.md file and a tool call logging and auto rebuild plan.md file if you want to dig deeper. The end result is kind of cool. You can ask the AI, is there a continuity problem with Alice between chapters 3 and 7? And it will walk the graph, show you the conflicting paragraphs because it actually traversed there, and then offer to fix it, but only with your blessing on every write. Try doing that with any of a pile of embeddings. You can't. If you want to copy these patterns into your own app, the easiest path is to honestly clone any one of these 2 repos and then use it as a template. Use ADefHelpDesk Graph Explorer if you're doing a read-only project, or AIStoryBuilders if you need AI to also edit the data. Both of these projects are open source. Both links are in the description. You could even point your favorite frontier LLM model at the repos and ask it to simply adapt the pattern to your own entities. That's literally what I did when I created the applications. So look, knowledge graphs are not some futuristic enterprise thing. They're a data shape your brain already uses. They answer questions vector RAG cannot. And the only reason most teams haven't adopted them is because the industry has trained us to think that knowledge graph means expensive database. It doesn't. If your domain is bounded, like help desk tickets, novels, customers, orders, whatever, you can ship a really useful AI-queryable knowledge graph as a simple JSON file with 3 C# classes. Pair that with Microsoft Extensions AI, and you've handed your LLM something way more powerful than a pile of embeddings. You've handed it structure. If this was useful, please smash that like button, hit subscribe, and let me know in the comments what data in your app is secretly a graph. I read every comment. I'll catch you in the next one.